Hi, in this video, we're going to talk about DHCP for IPv4, Dynamic Host Configuration Protocol. Okay, so in IPv4, it's pretty straightforward. A host is configured typically to obtain an IP address automatically, in this case meaning IPv4. Sends out some information to broadcast saying, hey, who out there's a DHCP v4 server, send me what you got. And the DHCP v4 server will say, hey, here's your IPv4 address, subnet mask, default gateway address, DNS server address, and maybe a few other things as well. So fairly straightforward. Matter of fact, it's really the only option of obtaining the address information automatically. Okay, so DHCP. So kind of looking at it from this is a view I always tend to like to go over. Here's a client sending out a DHCP discover message. We'll talk about the different messages in a little bit. But you may have multiple servers, DHCP servers on your network. So it sends it out as a broadcast. And then one or more servers may respond saying, hey, here's your IPv4 address, subnet mask, and other information. Typically, if there's multiple DHCP servers on your network, which isn't usually the case, but if there are, the client will usually accept the first one that it receives. So then the client will send out another broadcast letting that server and any other servers know which one it has chosen. Then the server that was the one that was chosen will acknowledge saying, yep, you chose me. I'm acknowledging that I have received your request and I am going to allocate this specific IPv4 address for you and only for you. And also I gave you some other information as well. Okay. There's usually a lease time with this. When the lease expires, the client can ask to renew the lease. If that is acknowledged, then it will keep the same address. At any time, the client can wish to release the IP address as well, saying I no longer need this IPv4 address. Okay, so where are DHCP v4 servers located? Sometimes they are located in your home itself. Your home router acts as a DHCP server. It'll act as a NAT server, DHCP server, and as a router. Okay. It also might exist at the ISP itself. If you have a connection that doesn't involve some kind of routing from your home to the ISP, then typically the ISP will have the DHCP server in its own network. It can also be in a corporate network. Here we have a local DHCP server, and that can be either the router, a local router, or a DHCP server. In either case, that DHCP server, whether it's separate from the router or not, doesn't actually have to exist on your local area network. We do something called DHCP relay for that. That's for another discussion. And here it's just showing that it might be a shared router between you and the ISP. But so DHCP server can exist in many places. At home, it's typically your home router that's providing that service. In corporate environment, it's either the local router or another server somewhere on your network that's providing that DHCP service. Okay, and part of the configuration of the DHCP server will be the scope of the addresses, the range of the IPv4 addresses. So in IPv4, DHCP for IPv4, there's usually going to be some kind of starting address. Remember, in IPv4 address, we have first host, last host addresses. Well, a lot of times we want to allocate the first group of host addresses for things like our router, default gateway, and other devices that need static addresses like printers, servers, and that sort of thing. That may come from, typically it comes from the first group of addresses, can also come from the end addresses. So we typically want to have our pool starting somewhere after or be, away from that range of static addresses. So in this case here, the 10.10.10.11 is the first address that can be allocated. So the .1 through .10 addresses will be used for default gateway and other static devices. Okay, so as far as the messages, I like to think of as DORA. So when the client boots or connects to the network, sends out a DHC discover message, which is a broadcast. Hey, who out there is a DHCP v4 server? This is my MAC address. I need some IPv4 addressing information. An IPv4 address, subnet mask, default gateway, etc. The DHCP server will send back an offer. It says, oh, okay, here's an IPv4 address, lease time with that address and all that other information. And I will bind that to your MAC address if you accept this offer. Okay, if the client accepts the offer, it'll send back a request saying, yes, I would like to accept this offer. And this can be either a broadcast or a unicast. I would like to request your offer. And again, here's my MAC address. I'm accepting this IPv4 address that you are so kindly offering me. And the server will then acknowledge that, saying, okay, we're all set. I am allocating, reserving this IPv4 address for you with your MAC binding it to your MAC address for a specific lease time, for a certain amount of time. Okay, in the world of IPv6, it's a little different. Okay, this isn't about DHCP for IPv6, but I just want to remind you that it is a little different. So at IPv6, it all begins with the router advertisement coming from the router. So the router sends out a router advertisement message suggesting to all IPv6 devices on the link how to receive its IPv6 address information. Can use Slack, stateless address auto configuration, no DHCP v6 server involved. I'm everything you need. Matter of fact, I'm going to give you our prefix length. I'm your default gateway. I use my source link local address, which is the source. I use my link local address as the source IPv6 address of these messages, and that's the address you'll use for your default gateway. And you can create your own IPv6 address using the prefix and prefix length, either use an interface ID that's random or using your MAC address and EUI64. Okay, but it can also say, you know what, create your own address, do everything I told you in option 1, but go talk to a stateless DHCP v6 server for things like maybe a DNS address, the address of a DNS server. Basically, you're still creating your own address, and this stateless DHCP v6 server, the only thing it's going to do is hand out information to you and everybody else, which is the exact same generic information, like the address of a DNS server. It's not going to give you an IPv6 address for yourself to use. That's the job of a stateful DHCP v6 server, and is option 3. Option 3 says, you know what, I'm gonna suggest that you go talk to a stateful DHCP v6 server for all your information, except the default gateway address. They won't help you with that. That comes from my source IPv6 address of this router advertisement, which is my link local address, and that's what you'll use as a default gateway address. Okay, I would suggest, if you haven't done so already, or if you're interested, please look at my videos on dynamic IPv6 address allocation, where I talk about all 3 of these methods: Slack and stateless DHCP v6, and stateful DHCP v6, and also talk about EUI64 and the privacy extension. Okay. All right, hope that helps introduce you a little bit to the world of DHCP for IPv4 and a little bit for IPv6.